Alright, so here's our warm-up. It's Friday! A circle is inscribed in a quadrilateral whose four angles have measures 85, 76, 94, and 105. Find the measures of the four arcs between consecutive points of tangency. Woo, that's a mouthful. So let's make sure we put the figures in the correct spot. The circle is inscribed in the quadrilateral. So make sure you put circle inside quadrilateral. I want to make sure to not make it look like it's a rectangle or a square necessarily. And then I need to try to draw a circle. Do the best I can. All right. And the angles are 85. That color is hard to see. 85, 76, 94, and 105. We want to find, I'm just going to call this points A, B, C, and D. So we need to find what it's asking for is arc AB, arc BC, arc CD, and arc DA. Let me give you a little bit of time to work on. Let me see if I can lead y'all a little bit. So let's just take one of those angles. Here's the circle. And this is not drawn to scale, sorry. That angle is 105, and I'm trying to find that arc. Here's A and D. Do you think you could find that arc if I single out just one of those angles, if we're only going to use one angle at a time? Okay, Carson. What do y'all think? Could you find X? What would you call this arc right here? I would not call it Y. I would call it something in terms of X. No! To find an angle outside a circle, you subtract the arcs and divide by 2. Here's an arc and here's an arc. So I'm going to subtract my arcs and divide by 2. And that's going to equal 105. Let's multiply by 2. 360, I'm just combining like terms. 360 minus 2x equals, 210. So then I would just trade places with the 360 and the 210. Or sorry, with the 2x and the 210. So I would add 2x to both sides, and I would subtract 210. So 360 minus 210, and then divide by 2. What are you getting? Good job, Albert. Good job, Helaman. All right, so in summary, we took 105, we doubled it. So let's do that to the next angle. Let's take 94, and let's double it. So 94 doubled, 188. Then we subtracted it from 360, 172, and then we divided it by 2, 86. All right, let's do the next one. 76, let's double it. Let's subtract it from 360, 208, and let's divide it by 2. Y'all getting what I'm getting? And now you can add them all together and subtract it from 180. Very good, Jenny. Yeah, sure. All we used was this. All we used was, hey, if an angle's outside, you subtract the arcs and divide by 2. If the angle's inside, you add the arcs and divide by 2. There's not too many theorems. To me, this is just like the quadrilaterals unit. Do you remember when there was parallelogram, rhombus, rectangle, trapezoid, kite, and you had to remember all of their properties? Well, the more homework problems you did with them, like a kite, the more homework problems you did with a kite, you weren't memorizing properties anymore. You knew, when you saw a kite, you knew to just stick that on it. You weren't recalling, oh, one of the properties of a kite, property number 2 was diagonals are perpendicular. You weren't recalling properties. You knew how the shape worked because you had done so many examples. The test is not until next Friday. So by the time we get to next Friday, you will have done so many examples that you won't be memorizing anymore. You'll be like, oh, inside, add the arcs and divide by 2. Oh, outside, subtract the arcs and divide by 2. So I'm hoping you do have more days to practice. You've got until next Friday. So I'm hoping that the more homework you do, have you been doing all your homework? The more homework you do, the less memorizing you'll have to do. More homework equals less memorizing. All right, my spiel is over. Let's check our homework answers. To give you enough time, I'm just going to work these 4. I think that would be a good sample of our homework, okay? All right. Do I have the homework open? No, that's a different one. Sorry. Let me grab that homework real quick. Geometry K, circles, segments. It's here somewhere. There it is. Starting with number 4. Oh, you got 7. Good. Okay. So starting with, oh, not 7, number 11. Starting with number 11. Look at 11 with me. It's really hard when you have to use a figure multiple times. So I kind of recommend to redraw that figure. If you're having to use a figure multiple times and it's starting to get confusing, then you can totally redraw it. So number 11, BD is 18, AC is 14, and CQ is 5. So we're going to use the theorem that pretty much says the part times the part of one chord equals the part times the part of the other chord. First thing I'm going to do is 14 minus 5, because I don't want whole pieces of a chord, I just want parts. So 14 minus 5 would give us 9. So I know 9 times 5 equals, I'm going to call one of these segments X. Then the other segment would be 18 minus X. Because I don't know either one of them. I don't know either segment. So I'm going to call one of them X, and I'm going to call the other one 18 minus X. All right? 45 equals 18X minus X squared. Move everything to one side. X squared minus 18X plus 45 equals 0. factor it. Three times 15. We want the 18 to be negative. We want the 45 to be positive, so they're both negative. So x equals two different things. It equals 3 and it equals 15 because we factored a quadratic, and therefore we have two valid answers. All right, number 12. Number 12. Okay, AC equals 15. I'm going to write it out here so my picture doesn't get too messy again. BQ is 9. QD is 4. Find AQ and CQ. So guys, this is really the same thing. But let me give you a different way to solve it now that we're doing the same problem again. Let me give you a different way to solve it. 9 times 4 equals, well, sorry, it isn't going to be much better. I don't have that much better of an idea. So let's just go with this one being x and this one being 15 minus x. 9 times 4 equals x times 15 minus x. Good. 36 equals 15x minus x squared. X squared minus 15x plus 36 equals 0. You factor it and you get almost the same thing as last time. You get 3 and 12. And then you just need to plug it back in to find AQ and CQ. Are we okay with that? Looking at number 15. Looks like we've got a triangle going on here. And we are probably going to have some sort of systems of equations. Let's look at this one and this one real quick. If we look at this one, we've got a tangent and we've got a secant. So we're going to use the theorem that says tangent squared equals whole times external. Tangent squared equals whole times external. Whee! All right. So 64 equals 36 plus 6x. Subtract 36 divided by 6, and you get a nice ugly fraction, 14/3. And then we can solve for w, but to solve for w, we're going to have to plug 14/3 into our picture. For w, we're going to do whole times external equals whole times external. So that's what we're going to do for w. So on that segment, the whole thing is w plus 4. The external is 4. On the next one, the whole thing is 5 plus 14/3, and the external is 5. So now we just go to our calculator for some calculating power. 5 plus 14 divided by 3 times 5. So when I clean this side up, I get 1/45, and I'm not even going to distribute. We'll just divide by 4. I'm always distributing, but there's other ways to do that. So I'm going to take that 1/45, I'm going to divide by 4, and we're still in ugly numbers. W plus 4 equals 145 12. 3 times 4 is 12. They're over 12, because the opposite of adding 4 would be subtracting 4 from those sides.